Well, we are back at it after Thanksgiving break, and we are picking up right where we left off with section 3.1, quadratic functions or parabolas. And we started this Thursday before the break, so check out the video right before this if interested. And a little bit of review. Remember, this is vertex form right here, and we call it that because where you see an H, that is the X value of the vertex, and where you see a K, that is the Y value of the vertex. So they could type the problem like that, or they might type the problem in what I call standard form, or I guess I should say many textbooks call standard form. And if they give it to you like that, you have to use a different method to get the vertex. So it's typed down there. We went over it on Thursday in that last video. We will use x equals negative b over 2a to find the x of the vertex. And then whatever we get, we'll plug back into the function and get y. So we'll practice that in this video. All right, so let's actually work a problem. We did number 1 last Thursday. Let's do number 2. Right away, hopefully you see this is in vertex form. And hopefully you can see the vertex. No work needed. You can just write it down. So I see a 3 where the h is on the previous slide. And remember, it says x minus h in the formula, so it's negative 3. And then it's just k, so positive 1. So whatever's in the parentheses, you need to flip the sign, and that's the x value. So there's one dot. And one thing I forgot to mention, if all I ask is for you to graph it, I need to see at least 3 coordinates. Now there's a chance the problem could be more specific than that, but if it just vaguely says to graph, I need to see 3 coordinates. And we have 1. One option is to look at x-intercepts, but hopefully you notice that would be a waste of time. See how we have a positive on the front right here? Let me change colors. There's not a negative there. So that means this thing does something like this. It opens up. It's not exactly like that. We're going to be more precise, but it opens up. That means it never crosses the x-axis. That means they are imaginary. No need to find these. Now, be aware, like if the vertex was down here and it opened up, then it would have an x-intercept. But the vertex is above the x-axis and it opens up. That parabola never crosses the x-axis, so that coordinate would not be useful at all. All right, maybe let's find the y-intercept. Make x 0. So f of 0 is 0 plus 3 squared plus 1. We can do that math in our head, right? We get 9 plus 1, which is 10. So there's a dot at 10, right up there. I need one more coordinate, and I already know what it is, because remember we have an axis of symmetry here. By the way, axis of symmetry is the x value of the vertex. But remember, the axis of symmetry is kind of like a mirror, and it can fold over perfectly on itself. So if there's a dot 3 units to the right, up there, top right, 3 units to the right of the axis, there's another dot right there. And we're done graphing. We have our 3 points. All right, let's try number 3. This one is in standard form. Whoops, I just clicked when I didn't mean to. All right. This is in standard form. And it is very different from number 2. I can't see the vertex. I mean, you could do a ton of math in your head and then maybe figure it out, but we can't just see it like we could on number 2. So we're going to use x equals negative b over 2a to find the vertex. Now some people struggle because they don't know what b and a are. So a is the front number, b is next to the x, and then there's also a c, it's all by itself. So let's plug into that little formula, and I get negative 4 over 2 times negative 1, which is negative 4 over negative 2, which is 2. But I need a coordinate, so I need to plug 2 back into the function. And then I can get the vertex. So that looks like 3. And I know my vertex is at 2, 3. So make a dot there. I need 2 more dots, and it does open down, so it does something like this. So it does have an x-intercept, but that doesn't look factorable to me. So I'm probably going to have to do quadratic formula where I can just see the y-intercept right now. Remember, if you make x 0, you can see the y-intercept. So plug in 0, and I get 0 plus 0 minus 1. The y-intercept is at negative 1. And there's another coordinate. Remember, we have our axis of symmetry. So we have another coordinate right there, and we have our graph. We have our 3 points. Now, for the sake of practicing, if it just says graph, then we're done. No more work needed. But what if it does specifically say find x-intercepts? So this is optional unless the question literally says find x-intercepts. So right off the bat, we hopefully notice this is not factorable. Use quadratic formula, which is negative b plus or minus b squared minus 4ac all over 2a. And I have a, b, and c listed up there, so let's plug them in. I have a negative 4 plus or minus 4 squared minus 4 times negative 1 times negative 1 all over 2 times negative 1. I end up getting square root of 12, which is why it wasn't factorable, because 12 isn't a perfect square. Then I need an actual dot. I need something more than just a square root, because, I mean, we could simplify this with nice numbers, but I need an actual dot. So I'm going to round and type in square root of 12, and I get 3.5. And we have 2 answers here. Remember, we got to take the positive and add it to negative 4, and we got to take the negative, subtract it from negative 4. So when I go negative 4 plus 3.5, I get negative 0.5 divided by negative 2 is 0.25. If I go negative 4 minus 3.5, I get negative 7.5 divided by negative 2. I get 3.75, and those are my 2 x-intercepts, which we pretty closely went through. I kind of missed it on the left there, but I think you get the idea. All right, let's do one more problem together. Number 4 here. This one is a very simple one. Just ask questions mainly about the vertex. And hopefully, part A you can just answer with no work. Does it have a min or a max? This tells me the parabola opens down. It looks like this. It will never get higher than that. That is a max, not a minimum. It'll never stop going down. It has no minimum value. So it has a maximum. And then they ask, what is that value? So we are not looking for a minimum. We're looking for a maximum, which is also the vertex. It's in standard form. I can't see it. It's not in vertex form. Like I can't see the vertex. So I'm going to have to use our handy formula here, where A is negative 3 and B is 6 and C is negative 13. I don't really need that. And let's plug in. So we get negative 6. Oops, I have too many negatives. I hope you caught that. There we go. That looks better. So it should be like that. And we get negative 6 over negative 6, which is a nice round 1. I need a coordinate, so I need to plug in 1. But that's pretty easy. Looks like negative 10. So our vertex or our maximum is at 1, negative 10. So look at my rough parabola I drew up there. I need to do the domain and the range. And looking at that parabola, it's never going to stop going left. Never going to stop going right. I know it's going down, but it's also tilted left and tilted right. So it's all real numbers. So make a capital R, make it bold. Or you can write the phrase all real numbers. Or you can write negative infinity to positive infinity. As long as I know you mean all numbers, then you're good. The range is limited though. It never stops going down. So this thing starts at negative infinity, and it does stop. If I scan this thing bottom to top, it stops at -10. And I know that because of the vertex that we just found. Technically, you're supposed to put a bracket right here and a parenthesis here. I'm not terribly picky on that, but hopefully that makes sense. See y'all later.